Hello everyone, welcome to our channel Boring Physics. Today our topic is Class 10 icse second chapter. We are going to start, that is work, energy and power. So today we'll start work, energy and power. So this one we are going to start work, energy and power. Work, energy and power. So first of all, we have to know about work. So, what is work? The first question will come. What is work? Work means, we can say, whenever we have to apply the force on a body will move. Means there is a displacement. Suppose if we say there is a surface, one body is in this position. Suppose body position is at A. Now we are applying some force on it. F. Now body reaches from A to B. Body reaches from A to B, this position. Okay. So due to apply the force, body reaches from A to B. So how much distance occurred? AB distance in a particular direction. So you can say this thing should be the displacement also. So what about the displacement? We are taking, suppose S is the displacement. So here work definition W equal to, you can say, force into displacement. Keep it in your mind. When we are telling that the displacement, there will be no problem, because displacement is a vector quantity. When we are applying the force, it should be along the same direction. If it is in the opposite direction, then work should be a different thing we'll get after some time only. We'll discuss that one also. Now the question, S is called that the displacement. Keep it in your mind whenever we are telling that the work is equal to force into displacement. Displacement. Okay, not that the distance. If you say that the distance, then you have to say in a particular direction. Then only it will be the complete answer. So if you say that what is work, by the formula you can say that work equal to force into displacement, or otherwise you can say that uh, work is done when force applied on a body, force applied on a body and makes the body to move, makes the body move. Okay, move in any direction also you can say. So W equal to, we are getting that the force into displacement. Now the question will come, what will be the, what will be the dimension? Now we are going to calculate the dimension, or you can say also work done means force into displacement, means the product of the force and the displacement we have done already. Now we have to know regarding the dimension. What is the dimension? Let's see. Dimension of force. Dimension of force. How we can calculate dimension of force? Let's see first. Okay, so W equal to, we can say that force into displacement, right? So force equal to what? We know that force equal to mass into acceleration into the displacement, right? So mass, we know that mass we can denote it as with respect to the dimension. When we have to calculate dimension, it depends on the three factor, right? That is m, l and t, means mass, length and the time. So these are the three quantities always determine that the dimension of any object. So m is denoted for the mass, l is for length, and the time is denoted as t. Okay, so now for this mass we are keeping same m. Acceleration means we know that length by time square. Basically acceleration means we can say that change in velocity per unit time, right? So acceleration means we can say v by t into s. Okay, v by t, v means velocity, velocity means displacement by time. So v equal to, I'm writing d by t and divided by this t, we are writing into s. So we can write from here that equal to mass into displacement by time square into s, another one displacement. So we can say mass into one displacement, another one displacement, and here is t square. Now we are writing with respect to the dimension, means mass, length and time. So m we are denoting as capital M, distance means L, by time, time means T, so we can write L by T square, into S is another one length. So what basically we can say? We can say M, L into L is L square, and this one is T to the power minus 2. So dimension of this is the dimension of force, right? This one is known as the dimension of force. Please keep it in your mind, everyone. From this dimension only we can say about the unit also, how we can calculate the unit of work from this dimension. Okay, so let's see. We have got that the dimension is ml square by t to the power minus 2, or sorry, ml square t to the power minus 2, or you can say ml square by t square. Okay, so what we can say in cgs unit, suppose I am writing first in case of cgs. In cgs unit, what we can say, cgs unit mass is gram, l means centimeter, means length is centimeter, so gram centimeter square divided by time, means we can say second square, gram centimeter square by second square. Okay, this one is in cgs system, and this one is known as arc. This one is known as arc. Gram centimeter square per second square is denoted as arc. And in SI system, if we say what will be the unit, let's see. In SI system it will be mass is kilogram, length is meter, so it should be meter square by second square. So it will become kg meter square by second square, that is known as joule. Joule. So SI unit of work is joule and CGS unit of work is arc. Now we have a relation in between them, so that one we'll see. So let's see first 1 joule. If we say 1 joule equal to how much arc, how much arc, that one we have to calculate. Okay, so let's see. So 1 joule, joule is the unit of work, right? So from here we can easily calculate. Let's see how. 1 joule equal to, we can say, joule is the unit of work, means force into displacement. From there also we can do 1 newton into 1 meter, that one also we can do, or otherwise by this formula only we'll do. Let's see, 1 kg into 1 meter square divided by second square. See, both the unit we are having that the time is same, so time we don't need here. Basically both the sides it should be same only, so we can write also 1 second square. Now we can see 1 kg means 1000 gram into 1 meter square, means 1 meter into 1 meter. So 1 meter means we can say 100 centimeter into, we can say, 100 centimeter divided by 1 second square. So we can say that what we are getting here is 1000 into 100 into 100. What will be the unit? Gram centimeter square by second square divided by 1. So what we are getting, how many zeros are there? 3 to 5 to 7. So we can write 10 to the power 7 gram centimeter square by second square. Here already we have written gram centimeter square by second square. It is denoted as arc. So we can write this one should be 10 to the power 7 arc. Please keep it in your mind, this one, that 1 joule equal to 10 to the power 7 arc. What is the way we can calculate? Please keep it in your mind. Important relationship between joule and arc. Okay. Now we have to calculate that the expression of work in the two component. One is component of the displacement along the force, and one is the component of force along the displacement. So here basically we can say expression of work, that one we have to discuss. Expression of work. So let's start the expression of work. Number one, we'll try to do by the process by finding the component of displacement along the force. Okay. So what is the topic? By finding the component of displacement along the force. So suppose we are taking one body. This is a surface. This one is an inclined plane. So one body is just in this junction position. Now, if we apply some force in this position F, the body is here, body will move. Suppose this position is A, body will move A to this position, suppose at C. Okay. So obviously it is an inclined plane. So suppose we are taking, this is the displacement component along AB. Now the question, whenever we are applying the force in this position, body displaces from A to C. What is the displacement? Suppose I am telling that the displacement occur equal to, suppose, S we are taking. Now we are going to calculate the work done. So we know that W equal to what? Force into the displacement, right? We know that W equal to force into the displacement. Now body displaces. So now we know that W equal to force into the displacement, but we are finding the component of displacement along the force. So what will be the component of the displacement in the direction of force? See, we are applying the force in this way. So the direction component should be along this direction, means along AB. Now we have to calculate AB. So that's why from C we have drawn a perpendicular on this point. So CB is the perpendicular. So if CB is perpendicular, this one will make an angle. So at a point A, suppose it's making an angle that is theta when the body displacing from A to C. Okay. Now what we have to calculate? We have to calculate work. So force F we are giving into, we need to calculate the component of the displacement in the direction of force. So component is this one along the direction of force is A to B. This one we can take. So we can take that AB. So the displacement component we are taking F into AB. Now ABC is a triangle, right? Right angle triangle. So we can say in triangle ABC, can we calculate? We are going to calculate along AB. So AB is the base, AC is the hypotenuse, and BC is the perpendicular. We need to calculate base. So base component means we know that base by hypotenuse equal to cos theta. So base equal to what? AB divided by H. Hypotenuse. Hypotenuse is here S A to C, means AC equal to cos theta. So AB by AC equal to, S equal to cos theta. So we can say AB equal to S cos theta. This only we know. Now F equal to, sorry, W equal to, we can write F into AB means S cos theta. So W equal to, we can write F into S cos theta. That is the, by finding the component of displacement along the force. Please keep it in your mind. Important note. Next topic we have to calculate. Number second topic we have to calculate by finding the component of force along the displacement. What we have to write? By finding the component of force component of force along displacement. Along displacement. So let's see. We have to calculate by finding the component of force along the displacement. Now suppose if we say this one is a surface, okay, this one is a surface. Now suppose that is the position A, and now we have to reach from A to C. This position we have to reach from A to C. Now we are applying the force. Suppose in this position we are applying the force, okay, and the body is in this position, right? So body should be in this position. Now we are applying the force. We have to calculate by finding the component of force. Keep it in your mind, by finding the component of force. Fine. So body reaches to position, suppose at C, means in this position body has reaches, right? Okay, so here also we are having the force, that is the F only. Same way the previous one, we are drawing a perpendicular on this position B, so it should be at an angle theta. Now the question is, we have to calculate which one will representing the magnitude, sorry, the component of force along the displacement. Now we are applying the force over here. Now suppose if we say, if we increase the line of action of force, so it should be in along this. Now if we draw a perpendicular in this position on, this one is A, suppose we can say on AP, and this one is suppose Q. So on AP we are making an angle, it should be 90 degree because we are drawing the perpendicular. If this one is theta, this one also should be theta, we are taking. Now the question, we have to calculate the component of force along the displacement. So displacement is in this direction, right? So force component of force along the displacement. So component means this portion, means PA, this one we have to calculate, right? So let's see first how we can calculate. We can say that W equal to what we know, force into displacement, right? Force into displacement, force into displacement is S, always we know. So S means this one is the S only, so already we know. Now the force we have to calculate, which one is the component of force along the displacement, that is P to A, that is the PA we have to calculate. So here we can write that PA into S. Now there is one triangle APQ. So if we say in triangle APQ, if we calculate, we want to calculate PA. PA is, if this one is theta, this one is 90 degrees, so this should become base, and this one is the hypotenuse, this is the perpendicular, right? So we can say that base by hypotenuse, base is PA, by hypotenuse is QA, base by hypotenuse is equal to cos theta. Now PA equal to what? We can write QA cos theta. QA cos theta, cross multiplication we did. Now QA equal to what? Force F. So we can say F cos theta. Now here PA equal to F cos theta into S. So we can say that F cos theta into S, means we can say component of force in the direction of the displacement into the displacement only. So W equal to, basically we are getting the component of this along the displacement or along the force, we are getting W equal to F into S cos theta. Now we have to calculate some special cases. Let's see. We need to calculate some special cases. Special cases. So we can say that the special case, it will always depend on the theta only. So what about the angle theta, how it can vary, that one only we can say. Number one, if theta equal to, we are telling that 0 degree. If theta equal to 0 degree, then what we can say, w equal to, we know that f into s cos theta, right? That only we have written. Now if theta equal to 0, so cos 0 should become 1. So we can say f into cos 0 degree. So cos 0 degree is 1. So we can say f into s. We are getting. So here we can say work should become positive. Means we can say that positive work done. Positive work done. Okay, this is the number one case. So in this case we can say, what about the direction of force and the displacement? They both are in the same direction. Means suppose we are applying the force in this direction and displacement also occur in the same direction. That is called the positive work done. Clear? Now the next case, if theta equal to 90 degree, keep it in your mind. Number 2, if theta equal to 90 degree, then what will happen? So w equal to, we can say fs cos 90 degree. Cos 90 is 0, so we can say f into s into 0. So ultimately it will become 0 only. So in this case, what will be the work done? Work done is 0. So we can say that here 0 work done. This type of question can come. They can ask that what is the condition for the positive work done, negative work done, or the 0 work done. In this case, keep it in your mind, displacement should be normal to the direction of force. Displacement will be normal to the direction of force. Here in the same direction, here is the normal. Now the last one we have left, that is number 3. If theta equal to 180 degree, then what will happen? Let's see. So w equal to, we can say f into s cos 180 degree. So cos 180 degree is minus 1. Cos 180 degree is minus 1. So we can say f into s into minus 1. So we can say that it will become minus f into s. So we can say here it should become negative work done. Negative work done. Okay, so it should become negative work done. Okay, so in this case we can say displacement, it should be the opposite direction of the force. Means if we apply the force is in this direction, so displacement it should be along in the opposite direction. So point is, suppose object is here, if we are applying the force in this direction, so displacement should be in the opposite direction. This one is known as the negative work done. So what are the conditions for the positive, 0 or negative work done? That should be the important question, it can come in the exam. Okay, so one more topic we are having in the work done period, we can say that work done by the force of gravity. Work done by the force of gravity. Work done by the force of gravity. What we can say, suppose we are having a mass, a body. Suppose we are having a body. So the body mass is, suppose we are taking m. It can be moved down through a vertical height. Suppose the body position is here, okay, at the position A. So body at a vertical height h. Suppose in this height h, either on the inclined plane or directly through a plane. Now what will be the force of gravity? on this position. So we know that whenever we have to calculate the work done, so work W equal to force into displacement. Now force is when this body is there, body having a mass m and body is coming in this direction, so means towards the acceleration due to gravity. So force equal to, we know that, mass into acceleration. So here mass into acceleration due to gravity, that is g. So we can write force equal to this. So force equal to, we can write m into g into s. S is the displacement. How much it is? H. So we can write that m g h. So we can say what will be the total work done. That should be mgh. So we can say the work done by the force of gravity is same. Whatever the body comes down from a certain height using the stairs or slope or the inclined plane or lift or elevator, whatever it is. So what about the total work done means W? It should become mgh. Keep it in your mind, important topic. Next part we'll discuss about power. Now we are going to discuss about the power. Now we are going to discuss about power. We have to know that what is power. What is power? Power basically is denoted as how much work is done per unit time. Okay, amount of work done per unit time. So we can say that it should become work by time. So means power equal to, we can say that work by time, or we can say that by P it is denoted W by T, work done per unit time. So what will be the dimension? Let's see that the dimension of power, dimensions is work dimension by the time. So dimensions of work by dimension of time. So we can say that dimension of work by dimension of time. So dimension of work already we have calculated, that is m l square by t square. So we can write m l square by t square means t to the power minus 2 and divided by this t. So we can write m l square t to the power minus c. That is the power. So power dimension is this one. We can say that whenever we have to calculate that the power, what will be the unit? What will be the unit? So units of power, that is also the important one. Units of power. One we have to calculate in cgs system. In cgs system, power means already we know that unit of work by unit of time. So in cgs system, work by time. So in cgs unit of work is arg and the time is always second. So you can say that it will come arc per second, or you can say arc second inverse. Same way if we calculate for the SI system, so work done in SI system, it should become joule. So we can say that joule per second. So joule per second, that is also denoted as watt. So watt equal to, we can say that joule per second, that is the SI unit, and CGS unit is arc per second. So this only we are having in case of the power. There is one question can come that what is the difference between work and power. Already we can easily say that work is the time independent. Suppose if we say What is the unit, what is the difference between work and power? Work and power. So first one is the definition, you can write. Number one is the definition, you can write definition, you can write for the both the cases. Number two, you can say that the time dependent or not, because work is the time independent. Next one is time independent work. Time independent is the work, and obviously power should be time dependent. Power is time dependent. Time dependent. And the number three, you can say that what about the units? Units of work and units of power. Units of power. Okay, so this way we can calculate that the we can write that the difference between the work and power. Okay,